Okay, good day everyone. I'd like to take this opportunity to explain to us how to write our report and also interpret our results. So first of all, we do the front page, which we already have an idea about it. Then we move to the table of contents. Yes, we already have an idea about this one too. Then we proceed to the abstract. So the abstract literally talks about the summary of the whole work, the work that we've done so far. So the summary is just the abstract is just a summary of the work that we've done, and we already have an idea about it since first year, second year, we've been writing reports and abstract and all of that. So abstract, you just try to summarize all the work that you've done to make someone who has not even done geophysics to understand in a simple way. Okay, then proceed to the introduction. So the introduction talks about electrical resistivity and how we can use certain electrical resistivity methods to deduce certain values or certain data to understand the subsurface properties of materials, or to understand the subsurface materials in the earth. And with this, we can also explain certain methods or certain array. For instance, the Werner array, the Schlumberger, the gradients, and so on. So you just give a brief explanation of them. It shouldn't be really entailed. This is just a sample that we are going to use, we are using, but your work should be unique in a diverse way. Okay, so from there we proceed to the methodology. The methodology tries to explain how we did the whole thing, and this is based on the work that we did. That's at the beginning of the semester, we went to field and all of that. So the how we're able to use the terameter, we're able to use multi electrodes and all of that to get our results. So we just give a brief procedure of how we use these equipments to get our results. Also, with this diagram, we can decide to label the diagrams to make our work unique. So yes, so you can also get different pictures online to set you apart. From there, we move on to the results and discussion, the main reason why this video was done. So this results and discussion really talks about how to interpret the diagram that we see here. Now with this diagram, we can see that we have different colors here. We have a range of red. You can see yes, a range of red here, and there's a move or violet. The dots here move or violet here. You can see there's a similarity here. This one is similar to what we did initially, and we also have green color. We have yellow, which also is similar in one way or the other. So with this value or with this picture, we try to get something out of it. So we have colors being displayed below the picture, and these colors represents the resistivity range. So we can see that here the blue, we have a particular number below which we have 109, 162, 242. For the green side, heading towards the yellow side, you have 361, 539, and so on. With the red side too, you can see that yes, the value keep increasing. Good. It means that the resistivity keep on increasing with the colors that we see here. But the values below is not a precise value. It's like a range. So you look at this place, we have 1792. It means that this place will be kind of larger than this, so you can predict or get somewhere 1950 here, because it's the number here should be greater than this. Okay, so what we literally want to do is, when you look at this diagram, you can see that with the red here, they all represent, you see the range represents values of resistivity ranging from 1200 to about 1950. So it's a range. Good. Now look at this diagram. You can see that we have a horizontal distance. So this is the horizontal distance, and we have the depth, which is the height. You get it? So this is the horizontal distance, the one that has been calibrated above. This is the horizontal distance, and as you go down, that's the depth. So with the horizontal distance, it starts from somewhere, and when you look, you have unit electrode spacing, which is the same as the calibration. So it means that each calibration stands for 2. So here is 0.2, 0.4, and so on. So when you look at where this red or this range of red started from, you can see that it started from in between the 2 and the 4. If you can draw a line or use something to just measure, you can see that this is not a digital thing or a really accurate measurement procedure. You have to assume certain of you make a reasonable assumption of the values based on your measurements. So you can see that it's in between. So you can see that this is 3 meters to the distance where it's raised. You see here we are taking the horizontal side, so 32, 34, 36, 38, 40. You can see that it ended at 40. You get it? So the horizontal distance for this one is from 3 meters to 40 meters. 3 meters to 40 meters. Now we come to the depth. So the depth is from 0.500 to, for let's say, you see where this is, because you are making a reasonable assumption based on the calibrations. So we can say that based on the numbers that we have here will be around 5.2. You see, around 5.2. So we can see that the depth is from 0.500 to 5.20. You get it? So if I want to say something about the resistivity of this part, because in the form of a box, I have to deal with the dimensions, so the horizontal side and the vertical side. So I will say that from a distance, or from a horizontal distance of 3 meters to 40 meters, and a depth of 0.500 to 5.2 meters, the resistivity ranges from 1201 to 1950, since we agreed that here the number keep on increasing. You get it? So if I want to do the same thing for this side too, we start from where this diagram started from. You got this color too is similar to this one, so we can assume that it's starting from here since the colors are similar. So we start from the edge of this. Where did they start from? So this is 34, 36, 38, 40, 42, 44, 46. You can start from 46. You see the 46. So 46, from 46 to 79. You see where it ended, 79. So we can say that if you want to describe the resistivity of this place, we can say from a horizontal distance of 46, from a horizontal distance of 46 to 79, and a depth of, as we agreed earlier, so the depth started from 0.5. You see most of the portion started from the above, so 0.500 to, when you draw the line, you can say it's similar to the first one, so you can just say 5.2 or even 5.0. So for only this part, you can say the horizontal distance from 46 meters to 79, the horizontal distance, let me open the work. Okay, so the horizontal distance from 46 to 79, and a depth of 0.55 to 5. The resistivity ranges from, since they are the same, just 1001 to 1950. You get it? Now we come to this part. This part is also part of the diagram, so we can't neglect it. But since yellow and green ranges in the same place, or they are similar, we can just assume, or we can just make our measurement based on the ones below, because they are all in the same range. So you can see that yellow, green, they are all below the ones that we measured above. So we can take the measurement from here, as in the horizontal side. So when you take the horizontal side, I'm taking the calibration from above here. So you just, here is 2, 4, 6, where the yellow starts from. So see the yellow, where does it start from? 6, it will be in the middle. So 7, that will be 7 meters to the end. To the end is 79. We have 75, sorry. Here is 70, no, this is 66, 68, 70, 72, 74, 76, 78, 79. So from a horizontal distance of 7 meters to 79 meters, and a depth of, now we just check where this thing started from. You see, you can just start from here, since this place wasn't part of the initial measurements for the first part. You can just take the measurement from here. You see, this is something that we just use our eye to make certain assumptions based on the distance that we see. So we just can use a ruler to just draw this line to a particular point. So if I'm going to take this one, I'll say that maybe started from let's say 6. You see, Because the range, you assume that this place will be, let's say 6. So 6 distance 6. So if I want to describe the resistivity of this place, I will say that the horizontal distance from 7 meters to 79 meters and a depth of 6 meters to 13.5 meters, the resistivity ranges from 300 to 800. You see the range. You see the range of the colors. So you can just say 300 to 805. So this is what they wrote here. And before you start the whole thing, initially in the previous videos, I told you that you should take pictures of certain things. Yeah, so if you're able to take those pictures, like the datum points, the maximum apparent resistivity values and things, this one will keep changing as the pictures changes. So you just include some of them. Then you come to the whole thing I've just described earlier. So you talk about different the parts. Talk about this part, and let's say this part too. So this part, I'll say this diagram is in 3 parts. First one, second part, and the third part. Good. So you just try to talk about them in relation to their resistivity and the depths and their horizontal distances. But this distance that we are just measuring is not there for anything, because these colors represent minerals. They are there for certain minerals. And how we will be able to get these minerals is based on a particular diagram, which I have to show you now. So this is a diagram which you can get online. Just search for resistivity rock ranges. They will just give you this. So when look at this, we have 0.01 to 0.1. We have 0.1 to 1. We have 1 to 10. We have 10 to 100, and so on. So every range in the vertical side, you see the ranges deals with certain rocks. So you can see that in the middle part here, if it falls between 10 to 100, means that a probability of being a clay, shale, lignite, freshwater, sandstone, sea ice. If it falls between this lane 2, it can be tills, it can be sandstone, it can be coal, it can be sea ice. The same thing applies to this side. So you just look on this picture, then you base on this to make your assumptions, or to make to just deduce the things that is capable of, or geologists are capable of seeing there. So you come to this side, you see this, yeah. So you can see that this one to the second diagram too, you can see you have different. I can see that this one you have first part, you have second part. So you just talk about the ones below, because the colors are all in the same range. You go to the next one. You see this one too. This place, they are similar. The yellow here too, and this one, you see they are in the same range. So you can just set that the ones below too as a different thing. Then you come to the last one. Yeah. So someone will be tempted to say that because here is blue, it is water. Because here is blue, maybe it's water. No, the blue colors, or the colors that we see, is just a guide to help us know the resistivity. And you can see that with various diagrams, the resistivity keep on changing. So this one, the resistivity values, it keep on changing. Good. So you just use the one that I've described to you to explain the rest. You just take the part of them to be this and that. So I think that's all for this one. And also, you see, for the first diagram, or for this diagram, let me show you this diagram. You guys, we have water here. So if we want to make drilling, or any company wants to drill something, because the resistivity here is low, we assume that if you want to drill, this will be the best portion to drill. So you can also include it in your result, because here the resistivity is high, and if the resistivity is high, it means that the rocks here will be hard enough, and that you drilling that place will be very difficult for you. Okay, so let's use this one to get the setting the rocks that is probably to be around based on the resistivity values they're giving to us. So look at 1200 to 1950. Look at the diagram. When you look at the diagram, 1000 to 10,000, it means that there's a chance of it being a gravel or a sand, a conglomerate, a dolomite, a permafrost. You get it? Or a duricrust. When it comes to this side, when it comes to the green side, which ranges from 300 to 800, it has a probability of being from, you see, in the range of 800. So here, It has the probability of being a gravel, tills, sandstone, coal, sea ice. So you just include them in the results. Okay, so now we move on to the conclusion. So the conclusion just deals with the summary of everything that you've done, just to finalize everything. So it just based on, due to Werner array, this enabled us to do this and that, and indeed it showed that if you use this Werner array and this device and all of that, you'll be able to get this value A and B. So we sent you the sample. Just go through the conclusion, make some amendments, and do your work uniquely. Okay, so you go to the references, which is so easy. Just make the references in the slide. Okay, so thank you very much, and I hope that we will all be able to finish this thing in the faster way and go back to our various houses safely. Thank you very much.